After analyzing different problems, we came up with the question, why does the floor get slippery when it gets wet? So we performed an experiment in order to get its friction coefficient and in order to determine if the water plays a important role in order to make the floor slippery when it gets wet. Our research question is, does water really reduces the static friction coefficient between two surfaces? Yeah. After having researched a little bit, we came up with the hypothesis that there will be more friction present in a dry floor, a little bit less friction when the floor is wet, and the least friction when the floor is wet with soapy water.
Here we have a drawing demonstrating how we will calculate the maximum static friction. The only ingredient needed in order to calculate the maximum static friction and then calculate the coefficient of the static friction is the angle, and we will measure it in two ways. The first one is going to be with a protector, and the second one will be using the arc sign. Here we can see the sketch of the problem. We use the Newton's second law and we use the problem of the inclined plane in order to model this situation. Here we follow a sequence of steps to know how to calculate the static friction coefficient.
Well, here we're going to start our experiment. To make this, we're going to lift the table when the object is in this part. So when we lift the table, we will know when the object starts coming down with the protractor on that part of the table.
In order to make our measurement a little bit more precise, what we're gonna do is that when we lift the table, we're gonna calculate an arc sign, and so we are going to measure this part first. Quickly, we measure, and it is 1 meter with 39 centimeters. We are gonna just measure how high this part of the table is, and with that we are gonna calculate the angle. Okay, so now we will proceed with the experiment. First of all, we need to get our object, which is going to be a shoe. We are going to place the shoe here and lift the table until it slips. That is the angle. We will now do the same but with water this time. We grab our object and repeat the same procedure. For the final test, we will perform the experiment one more time, but this time the surface will have soap. As you can see, the data from the experiment doesn't match the data from the hypothesis. That is why we decided to perform this experiment one more time, but this time with a metal pencil case. Here we have a table with all the results from both experiments. After doing all the experiments, we calculated all the measurements and we kind of were a little bit surprised because the least friction was when the table was dry. Then when we put water, it increased significantly. Then when we put the soap, it reduced a little bit but not not less than when it was dry. With this experiment, we can say that our hypothesis was wrong, and we have a lot of, well, some ideas of why this could happen. The first of all was because of the shoe sole, because when you put water like this, it gets sticky. That is why it increased the friction. The problem with that was that with the floor, it should happen the same, and it doesn't. The other hypothesis that we have is that the table has a different material than the floor, and it reacts a little bit different with water and with the shoe soles. And yeah, that's pretty much our conclusion.